I'm grabbing this worksheet and I'm kind of just looking at the first few problems. And they say, review, okay, so maybe I should know how to do this. It says solve the following triangles, so that's what we've been working on most recently, and that's actually what your quiz was on. But the problems don't look the same as the ones I was giving you, because I always gave you an actual triangle. This one just kind of gives me some information. So I just want to re-go over labeling a triangle and all that fun stuff. And then just how we solve. So usually I have been breaking the steps down for you. In this case, I just kind of didn't have room. So we'll just go through our steps again for 1, make sure we're okay with 2, and go from there. So number 1, it gives me 2 pieces of information. It tells me angle A is 32.6 degrees, and it tells me side A is 41.6. And that doesn't really help me because I can't visualize where things are. I don't know opposite, adjacent, hypotenuse, and that's stuff that I need. So what you're always going to do is draw a picture. You want to draw a right triangle. The only thing it told us is that C has to be the right angle. So the right angle has to be C. Other than that, you can put A and B wherever you please. I'll throw A here and B here. But if you flip them, it doesn't really affect you. You'll get the same answers. So just as a reminder of how we label triangles, this tells me that angle A is 32.6. So where I see angle A, just kind of in that angle, I'm going to label it as 32.6. Okay, so I know that. And then it tells me lowercase a, which lowercases represent sides, is 41.6. So across from the angle is the side. So if angle A is here, I go across, and that's side A. So those are the 2 things that I know. So as of right now, I don't know side B, so I'm going to have to find that. I don't know side C, so I'm going to have to find that. And then I also need that angle. I'll find that last, because that's kind of a quick one. So let's focus on our sides. Looking at this angle, I know opposite. So I'm just going to label somewhere, I know opposite. I need adjacent, and I need hypotenuse. So in this case, we'll kind of just pick. It doesn't really matter which one you pick. I'm going to say I'm going to find adjacent. You do need to decide, because once you decide, that tells you your trig function. So when I think about opposite and adjacent, I'm going to use tangent. So one of the most important things as we're doing these is the labeling. So we choose the correct trig function. Okay, so I'm thinking in my head, all right, I'm going to use tangent. My equation is going to be tangent of my angle, 32.6, is going to equal opposite, which I know, over adjacent, which I'm just going to call B, because we already kind of labeled it based on that. Sorry, my B's and my 6's always look kind of similar, so if you're confused, just write a different letter. This one is the one that had kind of 2 steps to solve it. I multiply both sides times B. And then for just one more step to get B by itself, I'm going to divide by tangent of 32.6. Most of you last week were pretty good with that step, maybe a few little mistakes here and there, but you kind of proved that you did know how to solve. I know a lot of times you can look at your notes, you can still look at them, not a big deal. So 41.6 divided by tangent of 32.6, B comes out to like 65.05. Oh, that's nice, so that can be filled in. Found that. I'm just going to stop for a second. I know sometimes it takes a second to write that stuff out. Oh. All right, so now as I'm kind of just finishing up that step, I think to myself, well, I still need other stuff. So I'm going to find that third side as the next step. Good old Pythagorean theorem always works if you know 2 sides and you need a third. It's labeled already with A, B, C, so I'm just going to fill in what I know. So I'm gonna do a squared plus b squared equals, I don't know what c is, so I'll call that c squared. 99% of the actual work is in the calculator. You just need to really set up so you know what to plug in. So I'm gonna throw that in my calculator. I don't know what it's talking about this on this big, 5962.0625. And since that's c squared, I am gonna take the square root of it. That comes up to like 77.2. Great. Delightful, I'm almost done. I'm missing one last thing, and that's that last angle. This is always my favorite step because it's kind of the easiest. I'm just gonna do the work right in my calculator. When I'm missing an angle, I know that a triangle adds to 180. So in my calculator, I'm gonna do 180. I'm gonna subtract the angles that I know. I know that one of the angles is 90, and I know that the other one is 32.6. And that will come out to 57.4. And now I'm finally done. I'll be nice. I'm not trying to kind of kill you. And I know it's hard to remember all the steps when I don't see you for all these little spurts here. So on an assessment, I'll try to kind of give you the steps. But after vacation, we're going to kind of move on and do something else. If we ever need it again, those steps will usually be there. So here's what I want you to do for 2. If I just gave you that information, can you just take a second? Can you draw the triangle? So if I just gave you sides, could you actually draw and see what it looked like? So can you take a second and try that? Take my attendance here. So if I just gave you information, would you know how to make a triangle out of that? And then even from there, can you try the next step? Because this one shouldn't be bad. You have 2 sides. Can you find the third side using Pythagorean theorem? And then I'll help you with the other parts. So that part, I feel like we've done that kind of quite a bit here. So if you have 2 sides, can you find the third using Pythagorean theorem? And then can you just visualize what that would look like in a triangle? Alex Modini. So give you another minute. We try those first 2 things, just setting up the triangle and then finding the missing side. So let's see if you were okay with kind of the first part. So number 2. First I look at that and I say, well, okay, just telling me this is kind of hard to visualize what the heck I have. We're gonna need things like opposite and adjacent and hypotenuse, and I definitely can't visualize it from here. So I'm always gonna set up a right triangle. So you need that right angle. C is gonna be my right angle. You can kind of put A and B wherever. So if you flip them, it shouldn't really affect you. And then just remember how to label. If angle A is here, we go across in that side A. If angle B is here, we go across in that side B. And I said, hey, if we have 2 sides, hopefully you can find the third one. just using Pythagorean theorem. So that's something that you should have been able to do. Even if you couldn't even set up the triangle, you could still do the a squared plus b squared equals c squared. I'm gonna do most of this right in my calculator, but I'll kind of set myself up. A squared plus b squared equals c squared. So I'm gonna throw that in my calculator. The nice part, I don't need to really rearrange anything. Okay, and I'm just gonna do the square root right in my calculator because I'm getting lazy and I don't wanna write it. And C comes out to be 87.7. So make sure you can get that. And the nice part about the next thing is I have all the sides, so I can really use any trig function I want. Hey guys, what's your favorite trig function? Someone yell one out. Someone just said, what? Sine, woo, okay, it doesn't really matter. It's just since you have every side, you can kind of pick whichever thing you want. So let's say I'm gonna do sine of theta. We know that's opposite over hypotenuse. So I'm gonna pick an angle, I'm gonna find A first. So sine of A equals, opposite of A is 30, and the hypotenuse is across from the 90 is 87.7. Usually if you were doing this on your own, I would give you a little hint that to find an angle, you have to use the inverse. And then I'm just gonna throw that bad boy in my calculator. I kind of like these ones. You don't really have to solve a lot, it's just knowing what to plug in. I always find that satisfying. I'm just gonna estimate it to 20 because it's 20.00 something. Close enough. And then that third angle is pretty easy to find because I have two of the angles. So I'm just going to do 180 minus 90 because I have a right angle, and then minus 20. I could have done that in my head, and that's going to be 70 degrees. Oh, what a beauty. So good reminder of what we've been doing, but just as a kind of looking at the original information in a little bit of a different way. So making sure that you can label a triangle. So I'll do that up for a second because I never want to rush you, especially if it's Monday morning. We're all a little tired. So all we're going to do today is I just want to write those steps. There's 3 steps to solving. They're quick. There's nothing too crazy to write. We are going to look at numbers 1 and 2 and try those, and then we'll kind of wrap it up. And in my last class, we did a little pass the pig. We can do that if you would like. And go from there. Ooh, excuse me. So number is 1. I'll put the steps over here. All right. So it says, what are the steps to solving an applied trigonometry problem? And there's 3 of them. So step 1. Step 1 is always going to be to draw a picture. You need to visualize what's going on. Now, don't just like draw, like, if you're artistic, I'm like the least artistic person in the world. Don't just like draw something fancy. Obviously, we're in for a class. So part of your picture should include a triangle. That's all kind of the main point of drawing the picture. It's having some sort of triangle come out of it so then we can actually do something with it. But being able to visualize is really the most important thing. Step 2, you're going to label the triangle. It's kind of a few steps in one. Pick a trig function and set up an equation. So they kind of all go together, so I put it as one step. But once everything's labeled, you make sure, okay, what do I have? What do I need? And then picking that trig function is the most important part of actually writing the equation. So that step, kind of everything's related. Then step 3, solve. Okay, so that's always our main goal. Can we actually solve the problem? I will add in, make sure that your answer makes sense. Right today, your answer makes sense. So we're actually talking about, real life things here. So if you said like, hey, the height of that building is negative 20 feet, that doesn't make sense. So you do need to, now that we have context, your answer needs to kind of make sense for that context. So just as a heads up. So I'll give you a second to write, because I know when I'm writing and someone rushes me. And then we're just gonna look at 1 and 2. No, shouldn't be too bad. Basically for all of these, I'm pretty much always gonna help you with the picture part. Some of them get a little weirdly worded, so I'm never gonna just throw it at you and tell you to do your thing. But now you should be pretty comfortable with solving. You don't need to, the nice thing is you don't need to solve for everything. You're just kind of picking one part and solving for it. So just focus on labeling and all that fun stuff. So as I read through number 1, Shelley knows that when she stands 123 feet from the base of the flagpole, the angle of elevation to the top of the flagpole is 26.7 degrees, okay? If her eyes are 5.3 feet above the ground, find the height. So I have no clue what's going on right now, so let's draw a picture. Because if you said like solve for this, I would say I have no clue how to do it. The main goal is that you can visualize what's happening. So we got Shelley. Here's the ground. So Shelley's standing here, as you can see, I'm like least artistically do there. Okay, she's standing here. Over here is a flagpole. The light pole, she's looking at it. She looks with her eyeballs. So from her eyeballs, she's looking to the top of this. That was a terrible thing. And I'm going to draw a triangle over. Okay, ooh, we have a triangle. That's always our main goal. Draw a picture, but make sure there's a triangle somewhere there. So now let's start labeling, because I still have no clue what's going on. Okay, she knows that she's standing 123 feet from the base of the flagpole. So from the base of the flagpole to good old Shelley is 123 feet. Okay. Once again, I'll kind of always help you with this part. The angle of elevation to the top of the flagpole, so that means her eyeballs are looking up, that's what elevation means. So that angle is 26.7 degrees. So from her eyeballs looking up is 26.7 degrees. It tells me her eyes are 5.3 feet above the ground. So that just means from here to here is 5.3 feet. We're gonna find this, so we can find the rest of the height, and then we can just kind of add them together. So as of right now, I'd pretty much always help you with the drawing the picture part. Unless we had ones that were very similar, but that's how I would set that one up. So I think to myself, okay, I have an angle. From this angle, I need this side and I know this side. Oh, this sounds familiar. Labeling. So from here, I need, and that would be opposite. I know this is next to it, so that would be adjacent. And that helps me pick my trig function. So you always go back to the steps that we've been doing for weeks here. What do you need? What do you know? What trig function are you using? And now you can plug into it. So we're going to do the tangent of the angle is 26.7 equals opposite over adjacent. So I'm just kind of throwing my things in there. I've done these enough that hopefully we're starting to get comfortable with where things are going. So we labeled it, we picked the trig function, we set up the equation, and now we're going to solve it. And the solving's not bad. You just multiply both sides by 123. We're going to plug that into our calculator. And the nice thing is, once we're done, we don't need to solve for anything else in the triangle. So that's always good. The less work you have to do, the better. It comes out to like 61.9. And then one more thing for this one. This doesn't usually happen, but it kind of happened here. We want the total height of the flagpole. That's just from there to there. So for the total height, we would do the 5.3 plus the 61.9. So just to finish out the problem, and my total height would be 67.2. I believe it's in feet. If nothing else for now, you just write it down, right? We're gonna do a few more tomorrow. We're not even gonna like kill ourselves on these. We're just kind of being exposed to them just to see what types of problems there are. And once again, you will not have an assessment on these. But you will try one or two things as we go forward with them. All we're gonna do is number 2. Then we'll wrap it up. We will do a little pass of the pig sesh. And then that's it. And I like number 2. Number 2 is even quicker than number 1, so that's always good. So number 2, I'll show you how to set these up. We have a building is 34.09 meters tall. It has a shadow of 37.62. Find the angle of elevation of the sun. So you've gone outside before, you've had shadows. Depending on the height of the sun, they kind of differ. Sometimes they're really long, sometimes they're really short. But here's how you would draw this picture. You have a building. Okay, so you don't, whatever. Windows, a little door, doesn't have to be fancy. So you're probably thinking, well, how the heck do I draw this? So somewhere up in the sky, you draw the sun. Okay, that's what makes shadows. The sun's rays come down, hit the side of the building, and then the shadow ends up on the ground. I feel like sometimes people want to put this as the shadow. No, that's just the sun's rays coming down. Shadows are always on the ground. So let's label, because once again, I wouldn't have expected you to know that unless I just showed you. The building is 34.09 meters tall. Oh, I can write that. 34.09 meters, that's the height. The shadow is 37.62 meters. So we said the shadow was the ground, that's 37.62 meters. And it asked me what is the angle of elevation of the sun. So that's going to be this angle. So when we look up at the sun, we want to know that elevation. I like this one. This one has even less work than that one. So first thing I think in my head is, what do I know? From theta, I know opposite and adjacent. So I'm going to use tangent. I'm going to say that tangent of theta equals opposite, which is 34.09, over adjacent, which is 37.62. And then I usually give you the hint, and I would if you were ever kind of doing this on your own, that theta, if you're ever solving for it, you need to use the inverse. But that's really all the work you have to do. It's really just the setup, and once you throw in your calculator, you're done. It'd be a good thing if I have my calculator. What do I get? Inverse tangent. Oh, there's you. I can't even read my own writing. 34, what is that? 34.09? Yeah, 34.09. So I'm doing the inverse tangent, 34.09 over 37.62. And it's going to come out to 42.2-ish. And that would be your final answer. So for now, I'll help you with the kind of setups and the drawing. We're just kind of going back to maybe solving for one thing, whether it's a side or an angle. We'll actually do stuff in the spring. I tried to save, I have like a few projects we can do outside. And one of them is we will actually find the angle of elevation of the sun using our shadow. It will be a blast. I'm sure you guys will love it. Excuse me. So that's the deal for today. So I'll leave that up for another few minutes. If nothing else, you just write it down for now. And then if you have questions, you can always ask them.